Hi, welcome back. This video is going to hopefully help you make good graphs using Logger Pro. First step is to download and install the Logger Pro application if you haven't already done so. At school, they're already installed in the science rooms. The Media Center, however, doesn't have the program installed, so you would need to do any work in the science rooms. But at home, you are entitled to a free installation of Logger Pro just because we own it here at school. So this is how you can get it. First, click on the class on our class website that you are assigned to. Log in. And in the course information section, there's a link called Instructions for Downloading Logger Pro. Click on that, and it will bring up instructions for doing that. If you are using Windows, click this link here. If you are using Mac, click this link here, and it will bring you to the Veneer website, or actually we'll actually download it for you, and then when you install it, it'll ask for a password, and the password is Climate. Now that you have Logger Pro installed on your computer, the first thing we need to do is set up our data table and then input our data. So to title your data set, double click where it says data set. The dialog box opens up, and we can label our data. So I'm going to call this buggy motion data. Click OK. We can see that we have a title up here. Now we're going to set our X and Y axes. So typically the x-axis is the time axis, but for our first lab it worked out that the x-axis was most appropriately the position axis. So I'm going to go with that, and I'm going to call this position. Again, double click on the X, label the column in its position. The short name is usually the symbol that we use in our formulas, and the symbol for position is X. And the typical units for position are meters. If you measured centimeters, that's okay. Put in centimeters. Most often you'll want to work in standard units of meters, kilograms, seconds. Click Done when you have that entered. Double click on Y. And our independent variable in this case was time. Again, that's not typical, but for this experiment, it was the correct thing to do in most cases. The short name for time is T, and the units for time are seconds. Click Done. Now our data table is set up. So going to start entering data, and this is just made up data. So when we were at 0 meters, our stopwatch read 0 seconds, and when we were at 1 meter, our stopwatch read 2.5 seconds. When we were at 2 meters, our stopwatch read 5.1 seconds. When we were at 3 meters, our stopwatch read 7.3 seconds. When we were at 4 meters, our stopwatch read 10.0 seconds. When we were at 5 meters, it read 13 seconds. Okay, and we can see that we have our graph drawn for us. Now we're going to do some work on the graph on the next slide. Okay, now that we have our data entered, we're going to format our graph so it meets all the rules of good graphing in physics. So to format the graph, the easiest way to do it is to right-click in the graph, select Graph Options, This is where we can put the title in, and this will be motion of a tumble buggy. Okay, so that puts our title in. Next up, some things that we need to do. We need to put our point protectors on our data points, and we do that by clicking this box. And then we need to remove these line segments. I call that going dot to dot. So we want to remove those, and then click Done. And you can see that our graph now looks a little bit more like the typical graph where we have each data point, there's a point protector around it. Now, one of the other rules is to use all of your graph paper. Use as much of the graph paper as you can. So there's a way of doing this on here, and it's called scaling the graph. Again, right click, go to auto scale, and we're going to auto scale from 0. That just means that 0 is going to stay on our graph. The origin will stay on our graph, and that's important for us. Nearly all the time we will want to have 0 in our graph. Now, that's how we format our graph. Now that we have our graph formatted properly, we need to start analyzing our data. And usually that requires us to fit a curve or a line of best fit. In this case, just looking at it, it looks like it's fairly linear. So I'm going to come up to the toolbar here. There's 2 buttons that control graph fitting. This one here for linear, and this one here for other more curvy curves. Okay, so since I know this is linear, I'm going to use that. I select the data just by dragging and click the button, and it gives us our equation for this line. And looking at this box gives us an equation. The time, the y variable, is equal to the slope times the x variable plus b, which is the y-intercept. So the slope here is 2.56 seconds per meter. Well, that sounds kind of weird. Usually we want meters per second. And that happens because of the way we collected our data. Okay, time was our dependent variable and position was our independent variable. So that's how we end up. And we can see that the line of best fit went through the y-axis at 0.09 seconds. Even though we had a point at 0, 0, the line of best fit doesn't necessarily go through all the data points. Very good. So this is what we want for the graph of our data. Now I want to do some additional analysis so that I can find the velocity of our tumble buggy. Could figure it out from here. This represents 1 over the velocity, so I could just take the reciprocal of 2.563, and that would give me the velocity for the buggy. But I want to do it another way. So I'm going to start out by making our graph look more typical. The way that I do that is I'm going to add a page, add another page to this graph set. I'm going to copy our current page because it has all the data that I need to start with. Click OK. We go to page 2, and now I'm going to do some formatting and adding additional columns, or an additional column. What I want to do is I want to calculate the velocity, and I can do that by adding a column by clicking that button there. Brings down this dialog box, and I want to add a calculated column. That means the program is going to do some math for me. Click that, and I want this to be my velocity, so I'll enter in velocity as the name for the column. And the short name for velocity is lowercase v, and the units for velocity are meters per second. Now I need to tell the computer how to calculate this value. So the first thing that I'm going to do is I'm going to click the function, and I'm going to look for a function that will help me find the slope of my line. Well, the slope is actually a calculus function called the derivative. So I'm going to click derivative, and I want to find the slope of the position versus time. So I'm going to select variable. I'm going to find the slope of my position graph. Okay, and now we're set. All I have to do is click done. And there's a new column here that tells me the velocity of my tumble buggy over time. Want to do a little formatting? I want to put this back in the more standard look, and I can do that by swapping my axes. So on my y-axis, I'm going to want to put my position and my velocity on the same axes. That way we can see both at once. Click OK. Now down here I have to change this variable to time. I'm going to auto scale my graph again, and now you can see I have data points for position and I have data points for velocity. I'm going to fit a line of best fit. They're both linear. I'm going to select both of them, click OK. I'm going to arrange my points, and we can see that we have our linear fit for the position graph, x, which is x, the slope times time plus the y-intercept. Okay, and we can see that our slope is 0.39 meters per second. Then if we go down to the slope for the velocity, or the equation for the velocity graph, it says the velocity is equal to the slope times the time plus b. Okay, and in this case the slope of the velocity graph is 0.004. That's almost 0 meters per second, which are the units for acceleration. So we can see our acceleration is almost 0, which means that the buggy was moving at a constant speed. We can get all of that from these two graphs. Now that we have our graph constructed, we'll want to print it out so we can include it with our lab report. Pretty standard printing operation. There's a couple of differences. So we'll go to File, Print. This print footer helps you put your, it puts a name in the footer. So since we're using a community printer, you'll be able to pick out your graphs. So put your group's name or the names of your people there. So I'll put my name there. It's going to show the date it was printed, the page title, the page number. You could click file name if you wanted to be able to go back to it, and it will print in black. That's what this dialog box does for us. Click OK, and then we want to select our printer. So I call this printer the Third Floor Science. It's actually the same printer that you want to select if you're printing from the science rooms. It looks like this, REH blah 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 3 blah 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 001. Okay, so that's the printer that you will want to select, and that prints to the middle science room, the science supply room. Okay, next thing that you want to do to make this appear better, to display better, is you want to change this to landscape. So you go to printer properties, and we want to change the orientation to landscape. That way our graph will be bigger on the paper. Click OK, and it should print. Thanks for watching the video.